This is the Rising Phoenix Dev, and I decided to go with the new format because I bought a face rig and, well, I haven't used it. So I might as well, especially considering you get this awesome Raptor avatar. But I digress. Today, we're going to look at something very interesting. We're going to look at the math of the Fibonacci series and the code, and see exactly how you transform the math into pseudocode into actual code. So without further ado, sit back, relax, and time to learn something new. So let's talk about Fibonacci numbers. And to start off, let's look at the Wikipedia article, and we're just going to go over the list of Fibonacci numbers that's showcased here. So for the first 21, as you can see, it goes all the way up to 6,665. And the sequence can be extended to negative index n by using the rearranged reoccurrence relation. Fn minus 2 equals Fn minus 1, which yields the sequence of a nega Fibonacci number satisfying f negative n equals negative 1 and to the n plus 1 Fn. Thus, the bidirectional sequence is negative 21, 13, 8, negative 8, 5, 3, so on and so forth. But how do you get Fibonacci numbers, you might ask? Well, the way they work is every number after the first two is the sum of the two preceding ones. So, for example, in order to get the 2, you do 1 plus 1. To get 3, you do 1 plus 2. To get the 5, you get the 2 plus 3. The 8, 3 plus 5, so on and so forth. So, how about the rule? The rule of Fibonacci numbers, or the Fibonacci sequence, is xn is equal to xn minus 1 plus xn minus 2. And it's a recursive formula, so that means we have to write a recursive function. So now, let's move on to actual code. Now, as you can see, I have a blank solution here in front of me, and I call it tutorial series. Straight up C# project, nothing special, nothing amazing whatsoever. So the first thing I want to do is I want to write out what the rule is. The rule is xn equals xn minus 1 plus xn minus 2. There we go, and I kind of have a little bit of OCD, so there we go. So now, we need a pseudocode example. So, in a code editor, it's really not advantageous to do pseudocode. So, what I can do here is, where is Notepad? Type it out. Notepad. One regular Notepad. There. So, we know we need a special number type because Fibonacci numbers can extend to an infinitesimal amount of numbers. So, we can go with double. We can go with float, since they have a high precision number count. Or we can go even further and go with big integer. Now, a lot of people aren't familiar with big integer, so let me explain that one. It displays really, 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 really big numbers. And I'll show what I mean later on in the code. So, let's go with a pseudocode. So we know, let's just go with the basics for doing double. So we'll do double here. Fibonacci. Now, we know we need to solve for n. So, double n. From there, we know that we need a starting number and one that adds the additional requirements, as we can see from the rule, which is xn minus 1 and xn minus 2. So let's go ahead and create a double for both of those. So what we're going to do to take care of that or satisfy that requirement, we're going to do a double A equals 0. And then we're going to do a double B equals 1. Simple, straight to the point, right? Then we know we're going to need a for loop where we have a value. We're going to call this x is 1. And if x is less than n, x plus plus. Start the loop. I know this pseudocode looks very weird, but kind of going with this kind of assembly-esque stick to it, but not really. So now that we have that, we know we're going to need a temporary variable to store this information. So we know it's going to have to be a double. And we would just call it temporary. And we would want it to be set to A or assigned to A. There. Now, we also want to assign A to B. So A is assigned to B. And finally, B is assigned to temporary variable plus B. End loop. And then we just return A. Simple, straight to the point, not really anything too complicated. But basically, every time it loops through, it's going to store the variables that A becomes as the temp. And then it'll add that temp to be A, which then increases the overall input at the end. So now that we have that pseudocode out of the way, let's get down to actually implementing it. So, static double. We're doing static because, well, we have a static void main, and I'm too lazy to do a conversion. So, static double Fibonacci double n double A equals 0, double B equals 1, or double X equals 0. We're going to start, since Fibonacci numbers originally started at 1, we could go with that route, but we're in computing, so we do best practices. Always start with your incrementers by 0. Then we'll do x is less than n, x plus plus. Simple, straightforward, to the fucking point, right? Now we're going to create that double temp variable, set it to be A, then A is set to B, then B is set to temp plus B. Then finally, return A. Simple, straight to the fucking point, right? Now, because we know this is going to be a recursive function and we want it to constantly be called until everything is satisfied, what we're going to do is we're going to do a for loop for double I equals 0, I is less than, you know what, let's simplify this and actually create a placeholder. So we're going to call this double start sequence, and we're going to set it to be 5, simplicity's sake. And I'm going to add that extra space, and we're going to say it's less than start sequence I plus plus. Then we're going to do console.writeLine Fibonacci I, and then a console.readLine make sure that we can actually see what's going on. Now, let's go back over here to our sequence, and we can see that setting it at 5, well, since we're starting at 0, 6 would be 8. So let's run this, and we should display 1, 2, 3, 4, 5. Now here we go. So we have xn equals 0, 1, 1, 2, 3. And of course it stopped at the 5th loop. Sorry about that. Kind of messed up my own math in my head there. Okay. Why the hell would I say 8? Oh, I was being a dumbass. Okay. So there we go. We can see that. So let's also take a look to see what the max in that sequence is. So that would be the 14th, which for us will be the 15th. Let's go ahead and set it at 15. And then run it. It should go all the way to 377. 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, 233, and 377. Exactly as it should be. But let's take this up to a ridiculously arbitrary number. And in my case, I'm going to go with 572. We run this, and we start off with all the right numbers until we get to this digit, which ends up becoming e plus 15. That's not what we want. We actually want it to display the numbers, but it's outside of the range of the double value. So what we're going to do here is we are going to copy that double Fibonacci, and we're going to say big integer. Now, big integer requires you to use system.numerics, which conveniently I already had set up. Oh shit, not what I want. There, so that's all big integer. And now you need to change the for loop to be big integer and the start sequence to be big integer. That way it does not go to Fibonacci, or the double Fibonacci. I want it to explicitly be this big integer one. So now, what happens when we run it? We get these massively large numbers. And it displays the full values for all of them. Never wavering, never faltering. It shows everything. And you can take this up to a ridiculous number. Let's see just how high we can take it. I haven't tested this part. So let's go with 100,000. Does it break big integer? No. You know what? Let's full screen this just so we can see the ridiculousness. Now, if you don't mind, I have to go eat these bitches for touching this computer the way they are. This is the Rising Phoenix Dev, signing out.